All right, let's talk about something huge. Something so fundamental to our world that we barely even notice it. We're going to dive into the history of mathematics.
Okay, I know what you might be thinking when you hear that word. Math. Homework, right? Maybe some equations that gave you a headache back in school. But let's just push all that aside for a minute. Because math isn't just about calculation. It's more like the secret operating system of the universe, the code we had to crack to understand everything from how the stars move to why the phone in your hand even works.
You know, Galileo really hit the nail on the head with this one. He said the universe is a book written in the language of mathematics. It's a language, and for thousands of years, we've been slowly, painstakingly learning how to read it. This is the story of how we went from just counting on our fingers to predicting the very fabric of reality itself.
So where does a story like this even begin? Well, it's not in some fancy university or a high-tech lab. Nope. It begins with survival. Pure, simple necessity. Early humans just needed a way to get a handle on the world around them.
I mean, picture this. You're a prehistoric shepherd. You've got a whole flock of sheep. How do you know they all made it back at the end of the day? You don't even need to know how to count in the way we think of it. You just need a bag of pebbles. One sheep goes out, one pebble goes in the bag. One sheep comes back, one pebble comes out. It's a simple, brilliant idea called one-to-one correspondence, and it's the absolute birth of the idea of quantity.
And as these little settlements grew into massive civilizations, well, their math had to level up big time. You had the Babylonians, who were incredible astronomers. They created a base 60 system to map the night sky. And get this, we still use their system today. The 60-second minute, the 360-degree circle, that's all them. Meanwhile, the Egyptians were using super precise geometry to build these gigantic pyramids and figure out property lines after the Nile flooded every year. For them, math was a tool, a very, very practical tool.
And this right here is the game changer. All these early empires, they knew how math worked. They had recipes, and if they followed the steps, they got the right answer. But it was the ancient Greeks who took this monumental leap. They were the first to stop and ask why. Why does it work this way?
And that one little question, why? Oh man, it changed everything. This is the moment when just doing calculations becomes actual mathematics. See, the Greeks weren't happy with just a tool that worked. They wanted absolute, universal, undeniable truth. And to get there, they invented their secret weapon, pure logic.
They came up with this incredible idea, the proof. A proof isn't just saying, hey, look, it worked the 3 times I tried it. No. A proof is a rock-solid, airtight logical argument that shows something has to be true, not just today, but always, everywhere, in all possible cases. This is what turned math from a handicraft into a pure science.
And nobody, I mean nobody, ran with this new spirit like Pythagoras and his followers. For these guys, math was basically a religion. They truly believed that the entire universe, the cosmos itself, was built on these beautiful, perfect relationships between whole numbers.
And here's the perfect example of that Greek obsession with why. You've all seen this theorem. But here's the kicker. The Babylonians actually knew this formula 1,000 years earlier. They used it. But the Pythagoreans were the first to prove it, to show with pure logic why it had to be true for every single right-angled triangle that could ever possibly exist. But here's where it gets really interesting. Their own devotion to perfect logic was about to lead them straight into a total crisis. They took their own perfect theorem and applied it to the simplest shape you can imagine, a square, with sides that are just 1 unit long. All they wanted to do was calculate the length of the diagonal. Simple, right?
The answer they got was the square root of 2, a number that just keeps going, a decimal that never ends and never repeats. It couldn't be written down as a simple fraction. It was irrational. And for a worldview built on the perfection of whole numbers, this was a catastrophe, a logical demon. The legend even says the guy who leaked this secret of the unspeakable numbers was drowned at sea to keep it quiet.
So, after all this chaos and discovery, this one guy comes along to clean it all up, Euclid. In his book, The Elements, probably the most influential textbook in history, he did something amazing. He started with just a few simple, obvious truths. He called them axioms. And from that tiny foundation, using only pure logic, step by step, he built the entire system of geometry. It was this perfect, beautiful, logical structure that would basically define math for the next 2,000 years.
So while Europe was kinda taking a nap during the Middle Ages, the mathematical torch was passed eastward.
And over in India, a concept was brewing that was so simple on the surface, but so profound it would change everything. And that concept was the number 0. Now I know, it sounds almost silly, right? The number for nothing? But this was a revolution. Other cultures had used placeholders for an empty spot, but Indian mathematicians were the first to say, no, this isn't just a placeholder. This is a number, a thing you can actually add and subtract and calculate with. It was an incredible stroke of genius.
And if you want to see just how powerful that one little idea was, just look at this. I mean, try doing multiplication with Roman numerals. Go ahead, I'll wait. It's a total nightmare. But with the decimal system, the one we use, the one that's built on the foundation of 0, complex calculations suddenly become, well, pretty simple.
This new, powerful number system eventually made its way to the great minds of the Islamic Golden Age. In Baghdad, a scholar named Al-Khwarizmi used it to create a brand new way of thinking, a systematic method for finding unknown quantities. He wrote a book about it called Al-Jabr, and from that title, we get the word algebra. He literally gave us the recipe for solving for x. So for centuries, math was really good at describing things that stood still, shapes, amounts, structures. But the scientific revolution was kicking off, and suddenly the universe didn't seem so static. It was a world in constant motion, and they needed a new kind of math that could keep up.
I mean, think about it. Here's the puzzle. You can figure out the average speed of a falling apple, no problem. But what is its exact speed at one single instant? That fleeting split-second moment in time? How in the world do you measure something that happens in no time at all?
The solution was calculus. And the core idea behind it is kind of like a superpower. It allows you to analyze a world in motion by slicing time and space into infinitely small pieces. If you can look at the tiny bit of change that happens across one of those near-zero moments, you can precisely describe things like instantaneous speed and acceleration. It's the math of change.
And the craziest part, this world-changing idea wasn't invented by just one person. It was created at almost the exact same time by two different geniuses, working completely independently. Isaac Newton over in England and Gottfried Leibniz in Germany. They both gave us the language to describe a dynamic universe.
All right, so for 2,000 years, Euclid's geometry was the law. It was considered absolute, unshakable truth. But then, in the 19th century, some mathematicians started asking a really, really dangerous question. What if we just break the rules?
Check this out. For 2 millennia, one of Euclid's most basic rules was that parallel lines never ever meet. It was just considered obvious. But in the 1800s, mathematicians like Riemann started playing this what-if game. They said, okay, sure, but what if space itself was curved? What if parallel lines could eventually meet? They came up with all these strange, beautiful, non-Euclidean geometries. And for decades, it was just a weird intellectual puzzle, a curiosity. Until along comes a young patent clerk named Albert Einstein. He was working on his theory of gravity and realized that this weird math wasn't a game at all. It was the exact language he needed to describe how gravity literally bends the shape of space and time. An abstract puzzle turned out to be the literal blueprint of our cosmos.
And that brings us to the final biggest question of all, doesn't it? We've just seen how math grew from counting stones to describing the entire universe. But did we invent this language? Did we create it like a tool to help us make sense of the world? Or was it already out there? A fundamental truth woven into the fabric of reality, just waiting for us to slowly discover it and learn how to read it. Is math an invention or a discovery? Now that is something to think about.